Hi, good morning. Welcome to the reading group. Just real quick, make sure I got all my chats up the way I need them to be. Wait for the streams to catch up. There's always a little bit of a delay. Are you streaming? All right, yeah. And yet, there we go. Okay, we're live. And not on YouTube just yet. Just give that a second to get going. How's everybody doing? Just real quick, make sure I got all my chats up. All right, that sounded awful, I'm sure, and we are good to go. Howdy. So, how's everybody doing? I'm here this morning, physically, in front of my computer, ready to read this paper. Who's excited? So this paper is a preprint. And I genuinely don't remember how I came across this. I think somebody sent it to me, or maybe I ran across it on Twitter, or maybe somebody on the research team was mentioning it. I don't know. I'm gonna be honest. I was gonna say I haven't read the paper. I never read the paper. We read it together. That's the whole thing. But it seems very relevant to what we do here at Rasa, building, conversational assistants. And it is by Gaurav Arora. I don't know why I came to this tab. It's on here too. Chirag Jain? Jayan? I'm sorry if I'm saying these wrong. Manash Chaturvedi? Chaturvedi? And Krupal Modi, all from Jio Haptik, which I'm not familiar with, but it seems to be some sort of tech company that works in the AI space. So let's get going. Abstract. Intent detection systems, and I can zoom way on in so y'all can see a little bit more. Intent detection systems in the real world are exposed to the complexities of imbalanced data sets containing varying perception of intent, unintended correlations, and domain-specific aberrations. There we go. To facilitate benchmarking, which can reflect near real-world scenarios, we introduced 3 new datasets created from live chatbots in diverse domains. Unlike most existing datasets that are crowdsourced, our datasets contain real user queries received by the chatbots and facilitates penalizing unwanted correlations grasped during the training process. We evaluate 4 NLU platforms and a BERT-based classifier and find that the performance saturates at adequate levels on test sets because all systems latch onto unintended patterns in the training data. Good afternoon, Dogbath. How much coding experience did I have before my PhD? A little. I'd taken a couple of CS courses. So for my undergrad degree, I actually double majored in linguistics and English literature. So I didn't have a whole lot of time to just take like random courses, but I did I definitely took the first CS course, which was Intro to CS. I don't remember if I took algorithms or not. I have to go back and check my transcript, and that was all in Java. And then I'd worked with R a tiny bit, and I had no idea what was going on. And I'd also worked with Stata, I think. SPSS? I don't remember what we did I took a psychology statistics course. So a scattering. Not very much is the answer. Okay, so intent detection is the task in NLU, natural language understanding, of figuring out, so mapping natural language input to a specific thing that a user wants to do that you can help them do. Yeah, no problem, Dogbath. So the authors here are like, hey, data that you get out, in the world from users actually is not perfectly balanced and beautiful, which I think anyone who has worked with user data is deeply aware of. And there's, lots of different things that can go wrong. So the varying perception of intent, this could be on the labeling side. So, if you have multiple labelers who are going through and labeling things as various intents, do they have like the same thing in mind? Or it could be, the way that intents can differ between systems. So you could have a very general intent, and then the more specific information is collected by, entity extraction or something. Hi, Gutham. Unintended correlations. This is a big one, particularly for what would you call them? Transformer-based language models. Wowee. So there was a paper on BERT a while ago that was looking at, hey, why does BERT do so well on these sort of like negation tasks that require some, if a human was doing them, would be evidence of understanding syntactic structure and formal logic. And the answer is because it was picking up on the correlation of, the word no, basically, to be like, this is the one that's negated. And domain-specific aberrations. I'm not entirely sure what aberration means here. I don't think that's a technical term. Just like different domains are very different, and your finance chatbots and your health chatbots are going to end up needing very different pieces of information to effectively work. And then they've got 3 data sets, and then they do some evaluation and find that performance saturates at inadequate levels on test sets because all systems latch onto unintended patterns in the training data. So, and this is just like a preview of what we're going to see in the paper. But basically they're saying, hey, if you are only training with your initial training data set and you don't update afterwards, then you're going to see less good results than you could if you were perhaps using something like conversational-driven development. They're not saying this, I'm saying this. Conversation-driven development, where you take in user data and you annotate and correct it over time and continually fold it into your model and do that sort of human-in-the-loop learning. Oh, and Gutham has some information. Haptik is a chatbot company in India, kind of popular over here. It makes sense based on the paper, just not one that I am familiar with. All right, introduction. Over the last few years, task-oriented dialogue systems have gained increasing traction for applications like personal assistants, automated customer support agents, etc. And a task-oriented dialogue system is, hey, I want to do something with my voice, as opposed to something like a chit-chat system where I just want to have, a conversation and not accomplish anything. This has led to the availability of several commercialized and/or open conversational bot building platforms. Most popular systems today involve intent detection, Rasa does, and/or open as a vital part of their natural language understanding pipeline. Recent advances in transfer learning, citations, Devlin et al. Is the BERT paper, have enabled systems that perform quite well on existing benchmarking data sets. So chatbots, popular, people use intent detection, transformers work pretty good. That's the background. Definitions of intent often vary across users, tasks, and domain. Perception of intent could range from a generic abstraction, such as ordering a product, to extreme granularity, such as inquiring for a discount on a specific product if you ordered using a specific card. For me, I would probably have I would probably not have this as an intent. I would probably have like inquiring about a discount to be one intent, and then do things like specific product and specific card as entities, just for ease of extensibility, and also because intent is a multi-class classification problem. The more intents you have, the worse your baseline performance is going to be. Just no free lunch theorem. More classes is harder, is just sort of the general point I'm making there. That's just my advice, is to have broader intents and get information from the, conversation elsewise. Oh, also, look, this is my mug. It's got a little business hedgehog, a little cupcake, a little coffee cup, a little briefcase. It reminds me of my hedgehog that passed. Additionally, factors such as imbalanced data distribution in the training set, assumptions during training data generation, diverse background of domain experts involved in defining the classes make the task more challenging. Yeah, and I would say that, so imbalanced training data is just a problem for multi-class classification systems. Data generation, really easy to, this is a big part of the reason why at Rousey we're like, hey, as soon as possible, get your bot in front of people. is because if you're just trying to guess what people are going to say, the likelihood that you're going to be right about it is kind of low. Like, maybe you'll be okay some of the time, but you're not going to be able to, like, as one person, sit there and generate the things that a bunch of different people using your system in different ways would. The best way to know that is to get your system in front of people. And then diverse background of domain experts. So, like, how much time has somebody spent building chatbots? You know, what systems are they familiar with? Things like that. During inference, once they're deployed, these systems may be deployed to users with diverse cultural backgrounds who might frame their queries differently, even when communicating in the same language. Yeah, really good point. Furthermore, during inference, apart from correctly identifying in-scope queries, the system is expected to accurately reject out-of-scope queries, adding to the challenge. So in Rasa, we'd handle these with a fallback policy. Most existing datasets for intent detection are generated using crowdsourcing services. To accurately benchmark in real-world settings, we released 3 new single-domain datasets, each spanning multiple coarse and fine-grained intents, with the test sets being drawn entirely from actual user queries on the live systems at scale instead of being crowdsourced. So this is like an ideal case in terms of data, that you have the data from the systems in production that people are using. But I am a little curious about the ethics implications here of releasing these data sets. So do all the people who provided data that was put in these data sets know that they were doing it at the time, and do they have a way to remove it from the data set if they want to? On these data sets, we find that the performance of existing systems saturates at unsatisfactory levels because they end up learning spurious patterns from the training data instead of generalizing to the perceived meaning of intents. Yeah, so overfitting, basically, based on, you know, statistical cues in word distribution that are actually not that important. I remember why I put this paper in my list. We evaluate 4 platforms: Dialogflow, Lewis, Rasa NLP, Haptik, and a BERT-based classifier on all 3 datasets, and highlight gaps in language understanding. Mr. Bingbo says, just joined, what's the paper today? We are reading HINT3, Raising the Bar for Intent Detection in the Wild. And I now remember that the reason this paper was on my list was because Rasa was one of the systems evaluated. Good job, Past Rachel. You had your stuff all together. Blah, blah, blah. Okay, so we're going to be Dialogflow, which is a Google project, Lewis, which is, pretty sure Lewis is the IBM one, right? Just gonna quickly Google in another tab. I should know this off the top of my head. Microsoft. So that's the Azure one. Sorry, I'm working at like 10% brain capacity right now. Not quite that bad, but definitely having a hard time the old focusing on work stuff. We further probe into queries where all the current systems fail and question the efficacy of the current approach of learning. Oh, interesting. Is this going to be about getting rid of intents? Additionally, we repeat all our experiments on the subset of training data and show a performance drop in all systems despite retraining relevant and sufficient utterances in the training subset. We made our datasets and code freely available on GitHub to promote transparency and reproducibility. Love to see that. All right, prior work. Despite intent detection being an important component of most dialogue systems, very few datasets have been collected from real users due to the, pretty gnarly ethical data collection concerns, mostly, I would say. I should actually say, there are lots of datasets that are collected from real users based on systems that are in production. The thing is, most of those are not available publicly because it's, private data, internal data. So these data sets exist, just like you as a random person looking for chat data are not going to be able to have access to them. Which is okay, right? Like it's fine for user data to be kept private. That's a good thing, actually. Web apps. Ask, Ubuntu, and Chatbot datasets from Braun et al. 2017 contain a limited number of intents, less than 10, oversimplifying the task. don't think the Ask Ubuntu data set is from that paper. I think that's from an earlier paper. I could be wrong about that. More recent data sets like HWU64 from Liu et al. And CLINC150 from Larson et al. Span a large number of intents in multiple domains, but are generated using crowdsourcing services. Hence, are limited in diversity in user expressions, which arise from, but are not limited to, domain-specific presumptions. Context from how and where the bot is made available, paraphrases emerging from cultural and ethnic diversity of the user base, conversational slang, etc. So they're saying these first data sets, artificial, not messy enough, basically. And the second data sets, because they're from crowdsourcing services, you don't get a lot of diversity in the answers. So you don't get a lot of different like levels of formality or people from different places, I think is what they're saying here. Yeah. Our work has some similarity with, that's probably C-Link, C-Link 150, in that they also highlight the problem of out-of-scope intent detection, and with Banking 77 from Casanueva et al. 2020 that focus on a single domain. However, all three of them offer relatively large and well-balanced training set, which might not always be feasible to collect for every new domain. Yeah, definitely. Particularly if you're, you know, I'm trying to come up with an example. You have a chatbot for your company that sells water flavor additives, and you want to people to pick what flavor they want their water to be. I don't know, man. Probably you're not going to find a pre-built data set that has like water flavor additives intents in it. For all data sets mentioned so far, recent work have reported reasonably high performance, greater than 90% average for in-scope queries. So I'm guessing that's average accuracy on intent classification, so selecting the correct intent. And sometimes you will do like top 3 intent, so if the correct intent is in the top 3, that counts as a hit. Presumably we're going to get a little bit more information on that. Hello, Yusuf. Despite this, gaps in language understanding become apparent when such systems are deployed. Datasets introduced in this paper and further analysis of results attempts to recognize critical gaps in language understanding and calls for further research into more robust methods. Which I would 100% agree. We're not there with language understanding yet. I'm trying to think like what NLP tasks. I'm like, yeah, we're there. Autocorrect. We're pretty good on autocorrect, and most systems, myself over a little bit, and most systems you have the ability to like update your corrections and customize them for yourself. So that's what I can come up with off the top of my head that we have like done real good at NLP for. Datasets. We introduce HINT3. This is the dataset, the name of the paper, it's their big contribution. A collection of datasets shown in Table 2. Soft Mattress, CureCart, and PowerPlay 11, each containing diverse sets of intents in a single domain. Mattress products retail, so buying mattresses, fitness supplements retail, and online gaming, respectively. Table 1 shows a few example intents of varying granularity in the HINT3 dataset, along with examples of training queries collected by domain experts and in-scope, out-of-scope queries, in-scope and out-of-scope queries, I'm guessing. Not queries that are both in scope and out of scope, because that wouldn't make sense. Received from real users. Let's pop up to Table 1. A few examples of the intents and queries. So here is the mattress data set. We have a generic and a specific one. So generic offers, and the specific, the 100 night trial offer. Offers, what are some available offers? Give me some discount. In scope, any other offers. Out of scope, if I order now, do I get a 20% discount in lockdown period? Okay, so I'm guessing they're saying like, hey, I want any offers, and this is too specific about a particular offer. This is a weird way to structure your intents. Let me rephrase that. This is not the way that I would structure my intents. And specific about this particular offer. What is the 100 night offer? Trial offer and customization, free 100-day trial, all of those are in scope, and then out of scope is I need to try. So this is training data that I think is question mark. I don't know how they got the training data. I'm guessing it's from earlier users who are using the system, maybe? I think they're going to talk about this in the next section. And then in-scope ones, and then out-of-scope ones. So can you recommend a product? In-scope, hey, these are the things that I specifically want. This is the training data. In-scope, more things about specific supplements, and then out-of-scope is like electrical advice, medical advice, it looks like. And then for this one, which is an online gaming set, they want to chat with an agent. So training example, in scope, things like, why is it showing the wrong balance? The balance is gone. I want to chat with a customer service agent. And then out of scope would be things like, why are my current basketball teams being shown? Okay, so this seems like a bug report, maybe? I'm guessing if I had to pick an intent for that. And it sounds like this is maybe like a betting app, possibly? I don't know. So these are just some examples. And I'm guessing... Is this... Okay, this is all... Sorry, I was just looking at these lines and I'm trying to figure out if these were different intents, but I think these are all the same intent. Okay. This figure's a little bit confusing to me. Okay, so that's what we got. How was it collected? So this is my big question. Again, just curious about questions about user privacy and sort of control over data. Training data was prepared by a team of domain experts trying to emulate real users after in-depth research of historical user queries. Okay, so these are utterances that are being generated by domain experts. These experts did not create an explicit set of out-of-scope queries, primarily because the universe of such queries is infinitely big. I mean, yeah, but the distribution of probabilities is not even across that universe, right? Like, you're more likely to get things that are almost things your assistant can do. And I think generally people know what those things are. Yeah, I appreciate that it would be difficult to write out-of-scope queries for everything that's out of scope, but I think it's very possible to write out-of-scope queries for things that, like, you're planning on implementing but haven't done yet, and you have a way of just being like, oh, check back next year. We might be able to do that in the future. Training datasets show class imbalance, occurrence of domain-specific words, and acronyms. All training data queries are in English, which is good for me personally, but maybe not ideal for this user population. Dataset variants. In addition to full training sets, we create subset versions for each training set. For each class, after retraining the first query, we iterate over the rest, discarding a query if it has an entailment score greater than 0.6 in both directions with any of the queries retained so far, i.e. the subset version has the following properties. So the entailment score is less than 6. Beans, that's either and or. What's the up caret in logic? Do I have my logic textbook near me? Nope, I think it's NAND. A and B have a... Okay, so A entails B, or B entails A, and A is not B. A as in the set of 1 to x sub I, B is in the set of 1 to x sub I for all instances of I. Let's read through the paragraph below that and see what we get from that. I is the set of all intents, okay. Xi is the set of queries retained for class I, okay. EHP is the entailment score function with H as the hypothesis and P is the premise. We use, okay, so the subset version has the following properties. Oh, also, I've been saying retraining. They say retaining. Mr. Bingo says, maths. Yep. Wouldn't be a machine learning paper if we didn't have at least one equation, which is not labeled here. Often equations will have like a little equation label so you can refer back to them, which tells me this is probably the only equation in the paper. Briefcase. I'm going to work. Subset for each class, retaining the first query, iterate, discarding both directions with any of the queries. Okay, so basically they're retaining the most diverse training examples for each intent is what I'm getting here. Presumably they'll talk about it more. We use an Elmo model trained on SNLI for EHP. Okay, so Elmo is a bidirectional model, and one of the, I think it's an LSTM model. I think it's a bidirectional LSTM, and it can be trained on I think it's a language model, but you can also use it as you can run softmax over the classes. I don't remember. I read the Elmo paper. It was a minute ago. It was probably like 2 years ago? I don't know. In there. And then SNLI is a natural language inference data set. So basically, this is a calculated score based on a trained model. And then there's some threshold, and entailment is not, reversible. So I have a pet, I have a cat entails I have a pet. So if I have a cat, it is true that I have a pet. If I have a pet, that does not entail I have a cat. So if I have a pet, it is not true that I have a cat necessarily based on just the statement I have a pet. So we're looking at AB, and if it's got to have like a certain level of not entailment, I guess. And then BA, we're looking for okay, so we are looking at both directions, and we're kicking out anything that super strongly entails care utterances. Do either of them entail the other? If so, chuck them. If not, keep them, as long as A isn't B. So they have to be two different utterances. And A is in the set of 1 to the set of intents. Set of queries retained for a class. For all intent I. Okay. And there's no repeats. I think it's just what that's saying. Pretty sure. Okay. I don't know that this is going to be super relevant to the rest of the paper. These are intended to evaluate performance with only semantically different sentences in the training set, as ideally systems should already understand semantically similar queries to the one present in the training set. Okay, that makes sense. And Allen NLP has a little demo for the textual entailment. Test data collection and annotation. Our test sets contain the first messages received by live systems from real users over a period of 15 days. And the reason just the first message is because NLU will often consider the conversational history. So if you want just sort of like a baseline result, the first message is often helpful, although it is possibly different where these systems are deployed, but often in the US, the first message to a system will be like, hi. So I don't know that that would be like super helpful in this particular example. Inter-annotate your agreement was blah, blah, blah for these respectively, and conflicts were resolved by domain experts. Oh, right. Okay, so the test set is hand annotated. Gotcha. Okay, so these are not system annotated. They are hand annotated. Gutham says, shouldn't they check for semantic similarity and not entailment? And how would entailment work for user queries? So I think they're using entailment here as a as a measure of semantic similarity. And the reason that you'd want to do that as opposed to like just raw semantic similarity is I want to order a pizza and I want to cancel an order for a pizza. If you're looking at sort of just the embedding space, have very similar embeddings. So if that's your measure, those are going to be, you know, very semantically considered semantically very similar, but from entailment standpoint, those do not entail each other, so they'd be kept separate. So I think the reason they're using entailment, and I'm not the author, so this is just me imagining that I were, is because you do want instances where the words used are very similar, but the way that they are, the intent that's expressed, the desire that is expressed isn't. Can you explain what today's paper is about? Yeah, so it's a system evaluation paper. So they're looking at different systems using a new data set that they've constructed of natural user-produced data for intent detection. So figuring out what a person wants to do when they are talking to a chatbot. Okay, so the test set is the first message, and it's being annotated by humans. And their enter-annotator agreement, so the amount of overlap between the annotations offered by the humans is sort of in the mid-70s. That's not awful for multi-class enter-annotator agreement, particularly for this sort of language data. I would say like above 60 is considered okay on sort of more of a qualitative side. One major reason for low enter-annotator agreement was unclear criteria for defining an intent, which sometimes led to overlapping intents of different levels of granularity, even after we made sure to manually merge any conflicting or highly similar intents in the training data. Yeah, so what counts as an intent got confused. Or what should be a separate intent, rather. There wasn't a strong agreement about. What's it called? I think annotating language data, annotating linguistic data. I have an NLP for developers video on the Rasa YouTube channel where I talk about specifically for annotation, you want to have like a central set of annotation guidelines. Zmook says it's kind of NLP, am I right? Yep. So it's, I would say more specifically, natural language understanding, which is a subfield in natural language processing. Yeah, absolutely correct. Directly coming from real users, our test set queries also contain messages, messaging slang, acronyms, spelling mistakes, grammatical mistakes, and using code mixed languages. I'm assuming here Hindi and English, or other, you know, languages of the Indian subcontinent and English. Check this out. Data exploration. Oh, so that's just a link to the data, so you could see more if you were interested. Weird that that footnote went above where it is in the text. LaTeX. LaTeX is the typesetting language that's used to write papers that look like this. Queries in non-Latin script or code mixed languages were detected as out of scope. Since live chat systems don't cater all the queries related to a brand, our test set contains relevant out-of-scope queries received from users about that domain. Any identifiable information of users' brands was replaced with made-up values in the both train and test sets. Any identifiable information? That seems like a very broad claim. I hope they're right, and I guess that's all we're gonna see or hear about the privacy issues of this data set, so I would want maybe a little bit more discussion about that. Yeah, and then this seems like this removing anything with any non-Latin characters in it. Presumably that does not include emojis, but I could be wrong about that. I also don't know how common it is to use emojis in sort of chatbot discussion with the specific domains and user populations they have. It seems like a pretty big limitation. Like, it makes sense if your audience is researchers who are always assuming everything's in English, but especially given their like user base, which seems to be people who speak English but also other languages, that might be, I don't know, kind of limiting. I don't know, man. It's definitely easier. It's easier to build a system that only handles one language. I have made a mess. Oh, landed on the screen printing and came right off. Fantastic. Okay. Metrics. We consider accuracy and Matthew's correlation coefficient as overall performance metrics for the system. Correlation with what? It's just a link to the scikit-learn. What's being correlated? We use out-of-scope recall to evaluate performance on out-of-scope queries and accuracy of in-scope queries to evaluate performance on in-scope queries. Okay, so they're using recall for out-of-scope and then accuracy for in-scope. And then accuracy and correlation, presumably correlation between the automatically detected intent and the actual intent. I would probably use F1 here. So F1 is the harmonic average of accuracy and recall, and given it's just like a little bit of a weird choice of metrics. And I'd like to see a little bit more explanation about why they did it that way. I don't think it's a bad choice to use correlation, but especially if you consider like an in-class, out-of-class for each, if you're looking at a per intent level, that might be more helpful. I don't know. Results. Figure 1 presents results for all systems for both full and subset variations of the dataset. Best accuracy on all the datasets was in the early 70s. Best correlation for the datasets ranges from 4 to 6, suggesting the systems are far from perfectly understanding natural language. So correlation runs from -1 to +1. The farther away from 0, the more correlated the results are. So for sort of like behavioral data, I would say a correlation of 0.6 is actually very good, just sort of on the, sociology statistics side of things. Yeah, but early 70s for multi-class classification like this is definitely a little bit low. If you're looking at, ACL papers, where I'd say for natural language inference, sorry, not inference, but this sort of intent detection, often you'll see results in like the 80s, 90s for accuracy. Let's check figure 1 though. Gutham says, so out of scope is a separate class label in the data set. Yeah, that's a great question, because they specifically said, hey, we don't have an explicit set of out of scope queries. So I don't know what they're measuring there. It is not clear to me. That's a good question. Okay, and then there's a whole section on out of scope prediction. So I think that that's going to be what they talk about there. Let's try figure 1 first. Take a little peek. So hopefully nobody's super colorblind here, and y'all can tell the differences between here. So for all of these, the non-dashed line, which is the full data set, Matthew's correlation coefficient and accuracy across all data sets and platforms. So this is the correlation coefficient, which goes from -1 to +1. And this has been truncated at basically random points, which I guess is okay because they're comparing system performance across different things. And then the threshold here, I don't know what they mean by that. Perhaps that's the threshold below which things become out of scope. So maybe they're doing this as like the way that we sort of handle fallback intent, so that you look at the confidence of the classification, and if it's below a specific threshold, then you kick it out, would be my guess. So this is for the sofa mattress. This yellow one is Dialog Flow, and it does pretty good until the threshold's about 0.5, and then it goes down. And it looks like overall for this correlation, the general pattern is that systems sort of like go further down once the threshold is raised, I'm guessing. And then the red here is Rasa. That's our system. And Rasa actually does pretty good with the full data set, and a little bit less good with the subset over time. And that holds for, not for this one, which is about buying supplements for exercising, I'm guessing. And it actually looks like across these ones, Rasa patterns with BERT, which is a transformer-based model, pretty strongly. And then Lewis, which is a Microsoft system, just sort of goes down over time as the threshold goes down. I'm hoping that they talk more about what this threshold is, because it's not entirely clear to me. And then Blue Haptik is their system, which actually has a pretty strong, across all three data sets for this correlation, a pretty strong parabolic relationship, so it sort of goes like that. And then BERT, which we already talked about. So in general, I would say all systems do better with the larger data set, except for BERT and Rasa with this last one, this Cure card data set, which is interesting. Yeah, and then so the correlation here is pretty low, right? So it looks like the middle of the pack is around 0.3, which I would say is like kind of no correlation. I wouldn't say that's particularly good evidence of a strong relationship. Here it's closer to 0.6, which I'd say is, you know, pretty good. And then here it's sort of like 0.5, which is not great. And I think the other thing that stands out to me is that Rasa and BERT are the two systems that seem to fairly consistently improve as the threshold increases, but I don't know what the threshold is. I'm gonna need a little bit more information on that. And then for accuracy, it looks like the different systems are handled very differently. And if I had to guess, I would say that this is a function of the number of classes in each of the system, but hopefully they'll talk more about it. So as the threshold rises, again, Rasa and BERT are patterning pretty closely together and are improving over time. Again, I don't know what threshold is. And the other systems are also patterning together more or less. So that is Dialogflow, Haptik, and Lewis. And for the sofa mattress, they go kind of up and then down. For Power Play 11, so this is that gaming data set, they just sort of go up as the threshold goes up. Accuracy, except for BERT. BERT with the full data set does not do as well. So this looks like, to me, potentially memorization. Maybe, I don't know. And then here again, BERT and Rasa are improving over time. When was this published? Was this after Diet? I would like to see more about, I don't know the internals of Dialogflow or Lewis. I would not be shocked if they were using some LSTMs. And depending on when this was written, our sort of default approach for intent classification like this is Diet, which is a transformer-based model, and BERT is for sure a transformer-based model. I also don't know what Haptik's using. So this could be sort of a model architecture difference between a more transformer approach and an LSTM approach, possibly. I need more information. Gutham says, I guess the probability threshold for classification for each label, and if none of the intents have that high probability, it's classified as out of scope. That would be my guess. I hope they talk more about it, because this was not as particularly helpful looking at a figure time. All right. And basically they're saying like, hey, numbers could be bigger, which is true. In table 3, we consider in-scope accuracy at a very low threshold of 0.1 to see if false positive on out-of-scope queries would not have mattered. What's the maximum in-scope accuracy that current systems are able to achieve? Our results show that even with such a low threshold, the maximum in-scope accuracy which systems are able to achieve on full training set is pretty low, unlike the 90+ in-scope accuracy of those systems which have been reported on other public data sets. And the in-scope accuracy is even worse for the subset of the training data, which I would say is not surprising because this is a system trained with less data, and general systems trained with less data do less good if they're a deep learning based system. What's the threshold? Right? Like, is that confidence? I don't know what the threshold here is. I guess we can look at table 3. In-scope accuracy at a low threshold. Okay, so for the full and the subset, general pattern systems are doing better with full and worse with the subset pretty much across the board. Here we have a very low threshold. So I'm guessing, I guess what they might be saying is like, hey, we're gonna say you're right if you give a confidence measurement of, you know, this, or greater than or equal to 10%. It's not really a probability, but greater than or equal to 0.1 to the correct class is, I think, what they're saying. Which is interesting, because if that is what that is, then it looks like, in general, the systems that are performing the best with a very high threshold, so you have to be super confident, look to be BERT and Rasa. With the exception of this this example. And this power play 11 accuracy seems to be very much the outlier in the general patterns here. Table 5 shows the percentage drop in in-scope accuracy across all systems as compared to in-scope accuracy on full data. The drop varies from 0.6 to 22.3% across data sets and platforms. In an ideal world, this drop should be close to 0 across all data sets, as if the system understands the meaning of the queries in the training data, its performance should not be affected at all by removing queries in the training data, which are semantically similar to the ones already present. Yeah, I get that argumentation. However, the measure of semantic similarity that they're using here is not one, right? They're using entailment, and these models are not trained on entailment. They're not trained to detect entailment. So I don't think it's necessarily surprising that if your measure of semantic similarity is entailment and you remove entailing, like, I think it's a good point, and I think for humans, it should not affect the way that we would do this task, right? Although I guess you'd need experimental evidence to suggest that that was the case. But I don't think that the measure of entailment is the same measure of semantic similarity as it's being, you know, operationalized in any of these models necessarily. I guess this really relies on what do you mean by understanding the meaning, and what's a good, you know, representation of that mathematically, overall, in just sort of like language and context, and specifically in the way that these models are trained. Analyzing few example queries which failed on all platforms in Table 4 suggests that these models aren't actually understanding the language or capturing meaning, instead capturing spurious patterns in training data, as was also pointed out in Bender and Kohler 2020, which we read. Yeah, no, I think that's true. I don't think any of these models actually have like a formal structural model of meaning. Predicting based on these spurious patterns, which models latch onto during training, leads models to have high confidence even on out-of-scope queries. Figure 2 shows this behavior on the soft mattress data set, as a significant percentage of out-of-scope queries have high confidence scores on all systems except Lewis, for which it is at the cost of in-scope accuracy. Okay, so let's look first at these. Well, we can look at this first. So what they're saying is these are ones that are out of scope. And this is out of scope recall. In scope. Oh, okay, I see. So the solid lines here are out of scope, and the dashed lines are in scope accuracy. So as you increase the threshold, in scope accuracy goes down, and out of scope recall goes up. Okay. And this is how much the accuracy dropped if you have the entailed subset of the data, which is, you know, quite a bit, and it looks like significantly more for the soft mattress data set and less for the CureCart. I would really like to see the number of intents here. Like, I feel like the number of classes in these multi-class classification data problems is pretty important. Significant. A significant percentage of out-of-scope queries have high confidence scores on all systems, except for Lewis. So they're saying is the line is highest for Lewis. I'm a little confused by this figure. But I think what they're saying is systems can be really confidently wrong, and that is a pattern that they are confidently wrong. So they're sort of like hallucinating class labels that aren't there. And let's look at these. So these are ones where so here the query is ergo 72 inches price. The true label is mattress cost, but the predicted label from all systems is the features of this mattress. Okay, and then here trial options are there. They're asking for the 100-night trial offer. All the systems except Rasa produce COD, cash on delivery, I'm guessing. And Rasa EMI, I have no idea what EMI is. You guys provide EMI, no cost EMI is available. I don't know what EMI is, but it seems to be something to do with payments that I haven't run into. Chirag says the number of intents is somewhere on page 2. All right, let's take a look. That would be helpful. Ah, okay, I see. We just never looked up there. Okay, so we have for the soft mattress. Thank you, by the way. 21 intents for CureCart, 28, and then for Power Play we have 59. So Power Play has about twice as many intents. It's this one, which could be part of the reason why it has such a different pattern with accuracy and the thresholds. Oh, and Gutham says, EMI, easy monthly installment. Ah, that makes sense. Thank you, that's really helpful. Also, Chirag, I'm assuming you're this one. What's the threshold? Could you let me know? I would appreciate that. This threshold right here in this figure. And if you are not the Chirag that's the author, I'm so sorry. I just sort of assumed. And I'm hopefully you are, and if you're not, sorry. But I think it's a reasonable assumption. Where were we? Yeah, so basically saying, hey, these systems are confidently wrong. They're making errors that a human wouldn't make. they can't, if we sort of filter the data in a way that would make it maybe even easier for human to do this task, the systems do worse because they have less data. Chuck says, it is as Gutham said. Okay, and then Gutham said, it's the probability threshold for classification of each label. Okay, so this is, I'm only going to classify this if the probability is 0.9 or above, and here I'm only going to classify this if this is 0.1 or above. So this is a very low threshold, and this is a pretty high threshold. I'm trying to remember what it was for dialogue, but I think we had a threshold of 0.6, 0.7 in there. So that would have been like around-ish here for the last live coding project. Okay, thank you, helpful. Truck, I actually am one of the authors. Oh, thank goodness. It would have been very awkward if you're like, I'm just a random watcher. I was listening silently, not to bias the reading process. It's always fun to see your paper being judged. Oh, well, thank you for chiming in. It is helpful to get some feedback from the authors. We had a lot of trouble because of the 4-page limit. Yeah, no, I feel that. So if y'all aren't familiar, ACL conferences have short papers and long papers, and short papers are 4 pages excluding references, and long papers are 8 pages. And 4 pages, especially if you have a lot of figures, is tight. You gotta get rid of a lot of stuff. So I definitely appreciate the challenge there. All right, so going through things that were misclassified. So some examples of queries. How will you deliver in the lockdown in place? COVID-19, how can you deliver? So these are questions specifically about the lockdown and COVID-19 and how deliveries would work. And the true label is that it's out of scope. Interesting. All of the systems said that this was check pin code. And examples. Oh, okay. Pin code here is like postcode. Gotcha. And not like a pin like you'd have on a debit card here in the US, which is just like a number that you use as like additional security when you use your card. Okay. Interesting. So they're all detecting pretty confidently this like, hey, can you deliver to my place sort of intent, where it's checking by a specific pin code. And the actual questions are out of scope. It's more about delivery options and no contact delivery for COVID-19 right now. Interesting. So size customization. I don't think we did this one. I require 75 inches by 57 inches. It is available. I don't think I've ever had the option to customize a mattress size. Interesting differences. So Lewis is like, hey, you're probably asking about distributors, like mattress distributors, I'm guessing. And then these other systems were guessing that this person was asking what size they should order, even though they had like the size and the intent. And then the predicted label would be, show me all available sizes, want to know the custom size chart. And then the true label, will I get an option to custom the size? Can I order a custom size mattress? Interesting. So perhaps this word available here is one of the things that's tipping the scale, which is what they're talking about, that these spurious statistical clues, these words that happen to show up in the training data, are influencing the intents in an outsized way. Conclusion. This paper analyzed intent detection on 3 new data sets consisting of both in-scope and out-of-scope queries received on 3 live chatbots over the period of 15 days. Our findings indicate that there's a significant gap in performance on crowdsourced data sets versus the real-world setup. So I'll save that for after I'm done with this section. NLU systems don't seem to be actually understanding language or capturing meaning. I think that's very fair. We believe our analysis and data sets will lead to developing better, more robust dialogue systems. So I think one of the things that this paper is like is pretty explicitly saying is like, hey, these systems that people are using to sort of like the data sets that people are using to evaluate their systems aren't good representations of what the data looks like in, I'm trying to, so the term I keep thinking about is ecological validity. So, hey, your model works on your specific subset. Will it, expand and be able to handle, the environment as a whole, right? And there's a very, I wouldn't say very contentious, but there's lots of people who's not super happy about it, trend in NLP towards leaderboardism, which has been a thing in computer vision for quite a while. And it's like, hey, you have a specific data set, you have a specific task, who can get the best numbers on it? And that's the main thing that matters. And I think what this paper is providing evidence for with these additional data sets and also these system evaluations is like, hey, that's not actually going to necessarily capture the efficacy of these systems in place, which I think is very reasonable. And as someone in industry, something I care a lot about, like, great, you did great on Switchboard, which is like a speech leaderboard corpus. Fantastic. How's it gonna work for like the people that are using my system? Is it gonna do good when I need it to? So yeah, I think it's a very very valid thing to bring up and a good thing to point out. And also, I think these data sets could be super, super, super useful, particularly if you're working with, this user population. So if you're working on a chatbot that you intend for people to use in India, I think these data sets are really, really helpful, particularly if they do have more of the code switching data shared, and if you have the ability to sort of handle some of that code switching. So like Hindi and English or other languages being used together could be really helpful and a good starting off point. And if you wanted to train like a convert type of model for dialogue, although I don't know that the whole conversations are available. Let's see. 3 live chatbots. Yeah, I think it's just the queries. Although we can check the GitHub. Did not mean to click on that link. We can check the GitHub because the data sets are available. So as a dataset paper, I think it is super, super valuable. As a system analysis paper, I think it is really helpful and good to look at. In the acknowledgements, we are grateful to the bot analysts at Haptik, especially Aaron D'Souza, who helped us open source the HINT3 datasets. We also want to thank clients of Haptik who allowed us to share queries received on their bots with the research community. So I'm guessing it's the clients who did the sort of user data collection telling. I don't know, man. I don't know how to say the word that I'm doing good. Handled the data collection stuff. Anyway, so yeah, and then the bigger point that like, hey, this is not, understanding, this is a statistical model that's capturing some correlates and it may not be capturing the correlates you want, particularly if you're not training on user data, is a great, great thing to bring up. Oh, and I can check which one of the Rasa models it is. I'm sure it's cited the first time they talk about it. There we go. Okay. When was this? October 2020. Okay, I'm pretty sure this is going to be diet for our classification. And also something that I know Alex has written quite a lot about. Nope, Alan has written quite a lot about is do we need intents? Like, is this task really a good proxy of understanding? Which I think is a bigger question. I think it's a very mathematically tractable proxy of understanding. I think it's a very easy to evaluate proxy of understanding, but is it necessarily the most helpful way of extracting the information from user-generated text? And I don't necessarily know that it is, and that this is going to be the sort of way that we build chatbots, continuing on to the future. I think most chatbots will include some form of intent detection, but I don't know that like every utterance needs an intent. You know what I mean? Anyway, just things we're thinking about. So that was the paper. HINT3, if you're interested in these data sets. There we go. They are available on GitHub, Hello Haptik /HINT3, datasets and the code, so you can check those out. And I'm just going to quickly look at the structure of these datasets because I'm curious. I don't think this is gonna... Does GitHub have a nice preview, or is it gonna download? Yeah, okay, so it's in a CSV. I don't especially want to open the CSV, but if you wanted to play around with these, they are available, and they are licensed, because that's always a good thing to know about. Open database license, so, which, as I remember, is pretty permissive. Any rights to the individual contents of the databases are licensed under the database contents license. So if you are using it for your work, double check that those licenses will allow the specific use that you're using. So thank you for joining me today, everybody. I hope this was helpful, or at the very least, distracting. I will be back tomorrow for live coding. I don't know what we're gonna do. Something. Maybe we'll just do the, like, putting in a number to pick the thing. Oh, maybe buttons. Maybe we'll do buttons. I think that's a good, like, I don't know. We'll do something. Yeah, thank you for joining today. Thank you for joining us, Chirag, and providing some additional context. It was very helpful. And I will see you tomorrow for live coding, and then next Wednesday also for live coding. Chirag says, thank you for reading. We'll update the preprint with more clarifications. Fantastic. That would be really, really helpful. Yeah, I think overall it's a solid paper. I mean, I had some feedback that I think I just like shared during the stream, but I think a really, oh my god, Docker, no. Don't, if you can avoid using Docker on Windows, please do. It's such a pain. Anyway, yeah, no, I think overall it was a solid paper. If I were, you know, reviewing it for an ACL conference, I'd probably, I mean, I'd have feedback, but I'd probably recommend accepting. Yeah, that's all I have to say. Sorry, I'm very hard time focusing right now. Have a great day, y'all. I'll see you tomorrow, and yeah, stay safe, stay healthy, take care of yourselves, and I'll talk to you then.